Hi everyone, it's Nono here and welcome to Live 13. This is week 13 of the live stream series. We've been covering a lot of machine learning topics, but this live stream also covers creative coding, workflow optimization, and many other things that have to do with design and how you can learn to use these creative tools for your own design projects. All right, so I have today, this is part of the Nonoma live series. And we've been in particular seeing the machine learning series over the past months. And today I will remind you, just go and like the video if this is the content you want to see in the future, or if you're enjoying the live stream and you want to see me keep going with this. And also to subscribe if you want to be notified of future live streams or when I go live next. All right, and the community, the Discord server is there, so we're growing as time passes. You can join at nono.ma/discord. Last week, we covered how to classify, just a little simple example project on how to build a TensorFlow Lite application on iOS. We didn't really see the step-by-step on how to build it. We just used a template that Google TensorFlow offers. You can run that on your device. I ran it on an iPad and we see how it works. And what it does is that it uses a classification model right on your iPad, showing classification tags that the camera is recognizing live. So you can go back on YouTube and watch that video. Let me know what you think. All right, this week I've published Goodbye 2020. We all know that 2020 has been a tough year. And for me, what I try to do is make a recap of what I've gone through. So for me personally, this year has gone a year where I've focused a lot more on the virtual medium, as we all have. I began live streaming, so I showed up for 12 consecutive weeks. This is week 13. I recorded podcasts remotely and published 15 episodes. I wrote and sketched daily and then published one story per week, making a total of 52 stories. That's 52 weeks a year. And then I released Sisyphus, a work that I did with Daniel Natoli, a short movie that we created in 2019, but then released in a few festivals and also on YouTube this year. I've delivered a few talks online, and I attended student reviews as a guest creator on Zoom, which was challenging. I am going to go just really quickly and see what that means on a browser, what those things that I have mentioned that I published look like on a browser if you go and want to browse through it. So this 12 consecutive weeks of live stream. So if you go to my YouTube channel, so that's at youtube.com/Nono Martinez Alonso, you can see, well, we're live streaming live right now, so this is ongoing. But apart from my uploads, you can go down here to the machine learning series and to the live playlist. If you go to the live playlist, so if we click here, you're going to be able to see from week 1 up to week 13 so far, right? Week 13 is the one that we're recording right now. And my intention is to keep building up tutorials. Each of them covers specific topics or a variety of different topics. And today we're going to recap what we've seen so far and what you can browse through in these videos, because I know that some of the videos are long and it's hard to navigate them. Still, one thing that I aim to keep doing, that I've been doing, I think, a good job so far on the last weeks, is that if you click on any of these videos, so let's say week 9, live number 9, you can come here, and if you go to show more, you're going to see, apart from the description and the links, you're going to see a set of chapters. What are these YouTube chapters? These are markers that allow you to browse the video in a better way than just scrolling through the timeline. Each of them has a timestamp, and you can also see, if we go into theater mode, you can see here that as I zoom in here, the timeline has these markers that tell us what content is on each of these timestamps, right? So this is a break, so you can skip it. You can come back to how to make a GIF. You can come back to Teachable Machine source code or uploading your model TensorFlow.js, right? If you click here on this marker, you'll pop up this panel here. Let me just put this here. So we click here, and then we get this view. So you can also get thumbnails for each of these key points or chapters of the video. And I feel that is really handy. I've watched other people's videos this way, and it's really nice. So you can see, for example, if we click on saving your Teachable Machine project, so we click here, lines on the menu, we then go down to download project as file, right? So you go right to that point. And I'm trying to do that with every single video that I release lately, at least on the live streams. All right, something else that we're doing. So if you go into the channel again, apart from those live videos, the machine learning series playlist has a set of videos that I've either recorded separately. Sorry for the overlap. All right, so the machine learning series playlist has videos that I've either recorded separately as tutorials or that I extracted from the live streams. So for example, the custom Python environments with Anaconda Jupyter notebooks, that's actually a tutorial that I've recorded and trimmed and then edited from one of the live streams, right? In here, you can see condensed how to build your custom Python environments, and there's other videos like Intro to Google Colab that teaches you how to use Google Colab or what it is, right? So that's the intention. We're recording live every week, and then we'll be uploading snippets of other things that you can consume independently, or you can browse through the chapters on each of the videos week by week. All right, next thing up is the podcasts. So we have, if we go here to gettingsimple.com/podcast, you're going to be able to see that we already have 41 episodes. The 15 latest ones have been released on 2020. The latest with José Luis García del Castillo. I'm going to show a snippet later in this presentation. And we have more. So we have many guests and also episodes that I recorded on my own, right? Starting with Tatiana Jambasova almost a year ago, we released that one. And, you can see more and more here. So it starts to grow and build up, and I'm pretty happy with the response of the community so far. So thank you for that as well. All right. Next up, I wrote and sketch daily. You might know this already, but if you go to sketch.nono.ma, you can browse, I think 80 or 70 different sketches and stories. So this is sort of a data set that I'm building as well, editing one sketch every week and also writing a short post. So you can browse them here, and they're available in Spanish and English, depending on the language of your browser. And, you can browse them to older to newer or newer to older. And for me, this is a private preview, but I can, preview the same post in Spanish and English. But, as you might do on your browser, if we change the language of our browser here, so I just put it in Spanish, this post that was rendering in English now gets rendered in Spanish, right? So it's just a matter of the locale of the website showing you one or the other. I always write the posts in English and then translate to Spanish for publication. All right, what's up next? Sisyphus. Again, if you go to the YouTube channel once again, the cover video that you can also access at gettingsimple.com/Sisyphus, the cover video that will show up, that is not here because I'm not. So let's just go to gettingsimple.com/Sisyphus. You can watch the short film that Daniel Natoli produced. Yeah, and I won't really spoil a lot more, but yeah, this movie is online. We released it on 2020 as well, so I want to thank Danny, and because I think he's done a really, really nice job. All right, and I'll stop this now. Okay, I deliver online talks and attended student reviews. Okay, so this part is covered. So next up is Scroobly. So Scroobly is one of the things that I intend to show over the next weeks. It's something that you can use on your own. Scroobly.com is an application that Google or the TensorFlow team created. Let me see who actually made it. It's like from this collective. Yeah, so this is, I don't think you can see it right now, but let me just zoom into here. So this is an AI experiment. So this thing means it's an experiment from the, I don't really know what it is, but there's a collective of people that are putting together applications like Teachable Machine and others that are samples that you can always find this. This is an AI experiment here. And those are provided or like initiated by Google and the TensorFlow.js community to showcase the uses of AI. So if you go to scrooby.com, you can click start here, and there's a process where you can build your own doodle, and when you're moving with the webcam, you can animate it. So for me, it was about trying to animate Crocodilla, which it's a bit hard because it's not the proportions of a human. But in some way it sort of worked. Okay. Next up, a clip from Jose Luis's podcast episode. This is out now. You can see the link below there. So it's gettingsimple.com/41. That's where you can, is the short URL to listen to this episode. It's available on YouTube, on Spotify, Overcast, iTunes, and Apple Podcasts, and Google Podcasts, and whatever. Okay, I'll shut up right now, and I'm gonna just let you listen to one of the clips.
You know how they say in English, when life gives you lemons, you have to make lemonade? So literally like 2 weeks into the full lockdown, the first one with the pandemic, I was like, I've been meaning to record online material explicitly. And I've always had excuses about why not to do that. I woke up this morning and I went online. I bought a chroma, a green screen. I bought a couple microphones, and I was like, okay, it's happening this weekend. Whatever it is, it's gonna be this weekend.
All right. So that's the latest episode is available now, and you can go and listen if you enjoyed. I had a really nice time catching up with Jose Luis. We hadn't been talking for a while in person because we couldn't travel, and we had the chance to reconvene. This episode has kickstarted the ALGO series. This is a series of meetings that we used to have when I lived in the US with Jose Luis, and you can hear more about it on the episode. Next up on the podcast is going to be Mike Gabor. So I've already edited that episode, and we're just getting the final details ready, but you can expect that episode early or mid-January. All right. And I think with that, we can code. So what I mentioned before that we're going to see today, so we'll close this presentation for now, is that, let me open these notes. So we have this document here. We've seen a few announcements, and I just wanted to go through a quick summary of the training tools we've used. I don't think we're going to do a lot of hands-on today, but just a recap. So I have here a list that says Runway, Lobe AI, Teachable Machine, and TensorFlow.js. We haven't really seen a lot of Runway on this live stream series yet, but I do have videos of Runway. So if you go to the, and the intention is I want to point you to the videos that already exist that you're going to be able to explore on your own if you miss them, or if you want to review some of these tools. Runway, Lobe, so Runway, Lobe, Teachable Machine, and TensorFlow.js. We see more things, and you can see it on the video titles of the live streams or on the chapters. But so far, I just want to cover these ones today because the 4 different interfaces that we've seen that let you train machine learning models with almost no coding experience, except for TensorFlow.js, which is, you're actually accessing the API of TensorFlow in JavaScript. In this video series that Nate Peters did a demo for, you can see they're similar in color. So we have the building a pix-to-pix drawing app part 1, part 2, and then sort of part 3 is missing, but then we have the demo that Nate gave. So in this one, so if we go, let's open up this one here.
Hundreds and hundreds of checkpoints that I think his students must have generated, but yeah, it's really extensible, which is awesome.
Can I highlight how it took?
Well, in this one, that it was part of the Digital Futures workshop that Jose Luis, Nate, and I gave in June, I believe, of 2020, virtually as well. You can see how Nate had wrapped the a Pix2Pix model to be able to be run with Runway. So in this case, Nate is giving a sample. Is showing a sample demo of how you could load an image and then get a prediction, and also you could use that live with other images and then use it with a different model to generate daisy textures, and then actually run the server live while you have this glitch application running, and then do live predictions by just drawing on a canvas, right? This is really cool. I think it's really nice that this works, and you can run it on your machine. If you have Runway, go to this glitch app and then set up the correct port and correct models. You can see here what we mentioned before. So right there, you have the YouTube video chapters where you can browse this video a bit better, so you can see the different parts of the video. So that's, these are 3 videos that we have there that will help you understand a bit more the role of Runway ML in the workflows that we're doing in this channel. So building a Pix2Pix drawing app with glitch, and then connecting it to Runway. So I will invite you to go and watch those 4 videos if that's what you want to do. I have Runway installed on my machine, and give me just 1 second to show you something. Well, my video is probably shift, so you might. Oh, all right. So the shirt says Runway, but the Runway logo is in green, so the chroma is actually hiding it. So yeah, it's a bit confusing. I can show you later, but the Runway team sent me a gift, so they sent me a few stickers and a really nice T-shirt. So I'll be wearing that at some point. All right, so this is Runway, and a new update is being downloaded into my machine, and they're up to version 0.15 so far. We'll see what version gets installed after this update downloads. Runway, for those of you who don't know about it, is a machine learning. They have like a model zoo. They have a place where you can. Let me just see update complete. Right, let's actually restart. So we're at 0.15.2. Let's actually close and open once again. Right, so we have 0.17.1 now. So we have a marketplace. That's the word I was trying to find. So we have a marketplace for models. So there are a few tools that they've already created to do video editing, automatic green screening, create your own models by training right on and creating data sets and training on Runway, quick actions like background removal, face animation, and other things. And if you go to the model marketplace, so we click here in models, and then we go to the more of the marketplace, there's models that many people have wrapped and put here, exposed here as Docker images that you can even run locally and download the Docker image and run it locally, or you can run it on the cloud. Some of these models require specific operations and tools and like CUDA drivers and things like that and GPU, and cannot be run locally. So you will only see the option to run them remotely. This one, for instance, seems to be a new or popular model that lets you create line art portraits, right? So you give it an image of a face or a portrait picture, and then it will try to generate like a line art portrait, which is really cool. Stylized neural painting. There are many things. Many of the ones that are here are object detection models and models that have been trained with StyleGAN too, which allow you to generate synthetic images of different from different data types, such as, I don't know, coral images or landscapes or skies, many things. And what we had here was this pix-to-pix model. So if I were to add that to a workspace, or I have that here, for instance, you can see that if I were to download the model locally, which I'm not going to do at the moment, I could run that and then have another application that is, or just select one image, or have another application that is requesting predictions. For that, again, you can go to those videos. I'm not going to show that right now, but heads up with Runway, they're adding a lot of new features and tools, and definitely a tool that I would use for teaching workshops and exploring how to use my own models that I train or models that other people have trained. Really nice to try out models that you don't know about and you don't want to spend a lot of time like on the command line or downloading the GitHub project and trying to make them work on your machine. It's like a plug and play. If we go into this one, for instance, you can see here that we have the run remotely button. So maybe we can go ahead and select an input from file. So we'll open a file. Let's try to find an image, it's a portrait, or maybe just go in here. Right, we gotta wait until Dropbox downloads. I'm gonna go over to the chat for a second, look who's online. Well, hi Sujay and Bea. Thanks for connecting online. Glad to see you around. And let's see if these, okay, so these loaded the image and the model's not working. So we can see here we could run locally. That option is not there. We cannot run with CPU. So just to reiterate what I was saying before, you can either run, well, you can either run local or remote and CPU or GPU. But in this case, this model only lets you run it remotely. If I go to my account, I have, I don't know, like I have some credits, and when I use this, it will use, I think, 0.05, so 5 cents per dollar per minute or something like that. So let's try running it and see what result we get. And this will take a bit to kickstart and to start the model. But once that is working, predictions will be really fast. We'll be able to export and save. So while that's going, let me see. Let me just try to find another portrait that we can use there. All right. So it seems, okay, so the model works now, so we can download this image. That's a funny result. All right. And now the model is running. So we're being charged for the seconds that, you know, the minutes that the model is running. And here it's a bit dumb because we're passing the same image over and over, and if it doesn't change, we're probably not doing any changes to it. Let's try loading a different image here. So open file, get this one. Oh, too big. All right, so maybe, yeah, so the image probably has been resized. We have a portrait here. I'm gonna save that. And maybe we can try the camera. So I have a green screen behind me, and this is probably gonna change the resolution. Oh, can we choose the webcam? Camera here, Logitech Brio. Oh, and I'm a bit deformed, squashed. All right, let's, well, we're recording live, so. So yeah, you can see, even though this is remote, there is like a really nice frame rate. Well, you get the point. So this is a model that we're running here. It's running on the cloud with GPU. We don't really have anything set up on our machine. We just downloaded Runway, and there is no need for us to set any TensorFlow operations or have any GPU on our machine. You can see that this model is running out from the webcam, and anything we do, we're just getting those frames. I'm not recording, so these frames will be getting lost anywhere, but I'm recording with OBS and we're live streaming. So this video here, in some way, I'm saving it. So you can see how it performs, how it works live. All right, let's stop this now. All right, so you know, we have that image. I'm gonna save that one at least, but we'll be able to get more frames later. And this is a really simple way where you can just start a model in Runway and get going to using it. There are options here in network, so we would be able to pass not only from the webcam, but also have an application that is pinging the service and then receiving the response, so doing that really quick or on demand or whatever you want. But you can have multiple models running at the same time, and this networking option will allow you to interact with the model from HTTP, socket.io, OSC, and I'm not sure what this Java query the model be. Yeah, JavaScript is actually just a sample post request to interact with the HTTP server. So this means that from JavaScript, you can build an application that calls this code and is actually connecting to this local endpoint. You can also host the model on the cloud. And here what you can see is that, you know, depending on the port that your HTTP server is running at, you'll get this code probably will adjust itself. And that is exactly the same number that we were seeing before on the video that Nate was showing. All right, so I'll say that this is a fairly nice model where, you know, we're getting like a face portrait of whatever face, so a line drawing of whatever face you put in there, and it works fairly well with other things as well. Okay, let's close Runway now. Let's see where I'm at. So I'm back here. As always, I need to reset my webcam settings. And it seems we're back. All right, so that was Runway. That's my recap on Runway. We're gonna go back to our cheat notes, and we can see here in our notes. All right, so next up we have Lobe. I have a link here which you saw before. This is the tutorial I did longer heard. This is a tutorial I did for Lobe. So Lobe AI is a tool that I've been following the development of really closely. This is a really awesome tool as well. Its functionality is different. So here you can use Lobe to label datasets or to bring datasets that have been already labeled and train models. So in this case, I was testing with a color and black and white dataset of sketches. Let me see. So I tried to build a dataset which failed. It didn't work. So data wasn't really working properly. And there is a part of this video in which I actually explain conceptually what Lobe's allowing us to do, right? You're drag and dropping images and you're telling the application which of those belong to each category. And then there is a neural network that gets trained that then lets you play with your data set and classify new images, right? The gist of Lobe is you get this interface here in which you can drag and drop images and then later get a classifier gets trained in the background. You can see the images here are labeled as black and white, and then after that is working, we can see which images were labeled correctly or not, and we can export our model. Here we can test it, right? So I was getting images from the web and actually trying those out with the model to see how they were going to be categorized. And then we also looked at how to serve the model locally. So if you go to the export menu, you can either export the model to different formats that you can use then later on other applications, on your iOS app, or on cross-platform TensorFlow builds or TensorFlow Lite also for mobile apps. All a local API. This is the same that we saw before in Runway, where you create a local HTTP server you can interact with from any programming language. And I put code here to interact from TypeScript, right? Similar to JavaScript. Exporting the model to TensorFlow Lite, we also tried that from Lobe. And then we use one of the examples that they provide to run that code and understand what's getting exported. We actually in this video also see the interactive Runway application. So I showed how to do what I was mentioning before, running the Runway model and then getting real-time predictions. Let's see if we do some drawing here so you can see it. So you can also see that in there. All right, so a bit more hands-on. Let's step back. Let's go to our desktop. Let's close this thing and let's see if we have the Lobe app. That's pretty cool. All right, update available. We've been hard at work on a brand new version of Lobe. Would you like to download it? Nice. All right, so let's also download and see. So there's new features here, like we can select the camera, something you couldn't do before. We can export to TensorFlow.js, which is awesome. ONNX, I don't really have experience with that. This is probably the local API. And so this is pretty nice. Accelerated GPU training, which I don't have, so this is not useful for me at the moment. More responsive, blah, blah, blah. All right, community, Reddit. Let's see what people are saying while this downloads. But yeah, this is huge that you can export directly to TensorFlow.js as well is really nice. And the fact that you can select different cameras is also really useful, because before you would be constrained to whatever camera was selected first, and that would be really annoying. All right, we have 1 minute for the download to complete. Let's see what's in here. Making corrections. Yeah, I guess. All right, so this is for Lobe, and I have some experiments here that I've tried before. So I tried Lobe saves these experiments as let's say projects on your machine, and what you can see here is that you end up with a set of classification experiments that you've run, and you can open them. So I could open this one, for instance, and once we open it, we can edit the data set, we can retrain, and we can add more data samples or remove other ones, right? The gist of this, as I mentioned before, we have a set of images that conform our data set, and we have the black and white and the color tags here, or labels in this data set. And if you open an image, you could change the label on that individual image and browse through them just to see. This is a really low resolution data set because I convert them to compress the data. I didn't want the images to be super big. And let me see what else we have here. Okay, and what you see here is that when I go into play, this is something that we also saw with TensorFlow.js in Teachable Machine, is that I can drag and drop images. So I could, or import. So let's actually import an image. So I have, let's say, this image that we just created today. So I import that, and it says it's black and white, which, to me is good, because I actually think this would be in the category of black and white. And I also have, for the latest post that I published on the blog that we saw before. So if we see this one, it loads the image, is also black and white. And the interesting part, as you might know, is that we train a model with the data samples we have, but then at a later date, we include new images that the data set hadn't, so they're not in the data and haven't seen before. So this sketch from a tree, I would expect it to be classified as color. Let's see what it does. Color, yeah. So it's working, right? And I didn't really have to write a line of code. This is the gist of all these tools that are arising, that you don't really have to write one line of code to get this classified. If you wanted to include this on the data set, we could go here on these two and say, okay, this is classified wrong or classified right. Or here you could reclassify it. And after you do this, this tells you add. So I'm going to click here on add the image to the data set. So we click here, and then Lobe gets to add that image into our data set, and it's retraining the model. Let's try to add one more just to make sure. Right, and I'm going to actually add Lobe to the sound system that you're hearing. That way you get some sound feedback as well when we train. Right, so let me just show you. So when I go here and click, and then I click here, you can hear that sound, and then we get another sound when training has completed. So you can see there is a bit of clever retraining of the model that happens behind the scenes, and then when we get that sound, that means that the model has been retrained, and that we can use the new model once again. So we could go here once more, and maybe this is a bit too big, right? Maybe this one, black and white as well. Okay, let's add it. And then this goes back to retraining. All right, and that's retrained. All right, so this is Lobe. I have, if we close this version, let's actually see if we can get the newest version that should be already downloaded on my machine. Okay, and while that extracts, let me see. Okay, Teachable Machine, TensorFlow.js. So Teachable Machine, and we're gonna see the new Lobe now, but I wanna keep moving a bit faster. So Teachable Machine, again, we also have a ton of markers here, and Teachable Machine, the recap is you have this interface, in some ways similar functionality to what Lobe AI is trying to let us do. You set your classes, you click on train, and then you get the model training automatically, and then you can export that model using on the web, right? So I go ahead here and click on, let me go here. So click on these classes. You can add as many classes as you want, then you will train the model, and then you will preview the results. When you preview the results, which we're not going to do today, one thing is that you can customize the variables on the training, and here I try to go into explaining a bit what each of those means. You also have really good explanations on the interface itself. And then when we click on training, well, after we add our images, right, you can either test from the webcam or from the image. This is a common practice, right? Like Lobe, Runway, and Teachable Machine, they all do the same. They let you test your model from the webcam or from images on your computer. The webcam usually is the best because you can get a sense of how the model is actually performing. Here I was just using images as we were doing in Lobe, where you can see how like that image of a lighthouse was being classified as color, which was wrong, but probably after training with more data sets, so with more images, that was better. Let me see actually if that is just a glitch. No, that actually was classified wrong, but then this one was classified right. So that's Teachable Machine, and you can also export to TensorFlow.js, host it on the cloud, or download the model, TensorFlow Core and TensorFlow Lite. Again, common practice everywhere. And I have here a few endpoints of that. So if I click in here, I don't know if you can see that link. I'll post it. So this link here, which I'll post, well, I'll just put it there, and you can see. Maybe we can add it to the video description. I'll put it on the Discord channel under the live events channel, so you can access them. And here my webcam probably disappeared or went tiny again. So this is me trying the model, so I didn't have to retrain it now because it's hosted on the cloud. I'm not sure if I were to add this, it still thinks it's color, but if I input a file, let's say we input a file from the images that we were inputting before, to see the difference in performance, I can get this sketch, which not working great. And if we get the color tree, that's color. All right, so there's one thing that happens here is that the data set is trained with images that are perfectly square, that have like a white background around, and then they have something in the middle. If you format images differently, and those are not formatted that way on your data set, then you will get bad results because the model hasn't been trained for that data format. All right, so this is Teachable Machine. Again, you can go here to teachablemachine.withgoogle.com. You can go into get started, and you can say image project, and we could train a model here, which, you know, it's not a big deal. So we're gonna do it right now. Let's say gray, and then we just have to, we can drag and drop. So let's actually try to go into that folder. We have Lobe there already, so let's first finish with this. So we're gonna go to, I think it was live here. Right, so in live number 4, we have these data sets here. So black and white images and color images. These are the same images. Oh, this is actually gray. This is actually color. Okay, maybe we gotta click there and drop. All right. So we have these two models here. So these two data sets, labels like black and white and color. So I think yeah. So these two here, let me move to the right, and this is the same that we did in live 12. So we can customize these things here, or we can click on train, we can click in under the hood right below here to see some of the things as they train. So again, I'll just move, and you can see those graphs there that as we train live, the loss is going down, which is good, and the accuracy is going up. Again, my webcam goes to the website. We can see some things here like calculating the confusion matrix and accuracy per class. Again, I think live number, some of the live streams cover a bit of what these two mean. And I'm here, so I'm being classified real time. I can choose other images, and now, you know, we've retrained this model, and now we're getting the proper classification. What I meant before is that, you know, if you click here on export model, you can either, you know, you could say upload my model to a shareable link, and this URL here that you can see will be filled with your unique ID for your model. I'm not going to do that right now because it's the same model that last time. You can also then later load your model with JavaScript in any web app or in P5, right? You get the code here. You could also download your model as a TensorFlow.js model to use locally or to host it on your own. TensorFlow Core, you can download as a Keras H5 model or as a safe model that is a more universal. Well, Keras is more universal, but same model is the TensorFlow safe model format, which is more TensorFlow idiomatic. And then TensorFlow Lite. TensorFlow Lite is to use on mobile apps, and you can also get it quantized or floating point. Quantized has less precision, but it's also smaller and is going to work, run faster. Right, let me show up again. Okay, HTPU, that would be for Coral devices. So these are like the, well, Coral devices are like hardware pieces that Google sells to run your models on a physical hardware that can run distributed operations. And you can also use TPU in Google Colab, actually. All right, so this was TensorFlow, so Teachable Machine, which is using TensorFlow.js on your browser to train a model, and you can customize things. You can understand a bit what's going on. One of the things that happens behind the scene that we saw in the live stream is these images are getting saved as 224 by 224 images. They're already being formatted to be trained on MobileNet, which means that it doesn't matter that the data you upload is not formatted. They will format it for yourself. And then if you go here to save project to drive or download as project file here, you download a file that then you can open in another tab, right? You can keep going even though this is now empty. I can go here and say open project from file and drag that file, the project TM, and it will upload all of my information. What we took a look at is that this file size is super small, and that is because it's just 472 KB. I'm gonna delete it now. Lets you continue, and the reason why it's so small is because the images that are saved here are only the really small images that this application needs to train your model. It's not actually saving the high-res images because it doesn't really care about them. All right, so we close this. We could host that model this way, so we could share it with other people to try it, to use it on their apps. Google is nice enough to let us just share them there. And if we go back here, we were seeing Lobe, and we're gonna just open our applications folder and replace with a newer version. Right, so we have here Lobe, still copying. Right, so we now have here Lobe, and we're going to execute it. Okay, I'm gonna save here for live 13. We're gonna save these images. We're gonna put here Runway line art. Okay, so we have the newer version of Lobe. Looks really similar, so we can go here and so let's see. One thing that was new, we can export to more formats. Before you saw only 4. Now we have TensorFlow Lite.js and TensorFlow. We have local API. We have the ONNX used for cross-platform apps. All right, and this is really cool. So what happens if I do now local API? Yeah, this is more or less the same. We get here the port and the URL for where our model prediction has to occur. So let me open a browser tab here so we can, yeah, so this endpoint gives us the information, right? This is a get URL, but we can also post to it, I think, and then predict. Let me see if we get nothing found. So this is our failed model, load for project, none, error value is none. Okay, so this is being hosted there, and we need to make a request. So we get code to make these requests on any programming language, which is really nice. JavaScript with plain vanilla JavaScript, and even from PHP, which is really cool, right? So you just set up this thing, and with any app that you're running locally, you can use it. So let's export to TensorFlow.js. That is one of the newest formats. Let's just export. And this will take some time. Haven't done this, but it seems it's pretty fast. All right, after we take a look at that, so we can look at the feature of using different webcams, which I think is nice. And we can make a quick recap on the TensorFlow Live 11 that we did. So that video covered just like the rawest features that you can use on TensorFlow for the web in order to train your own models or create your own models. In this case, this is a good moment in the video because we had the sequential model defined here. So this was the equivalent of building a model with Keras, but in TensorFlow.js, we set up the layers here, only one dense layer. We were just training a linear regression model, a linear classifier. And these were our data samples, right? So these were data samples, was like a matrix of 1D matrix of 4 items. And then we were training the model. The one thing that was interesting from this video is that, well, you know, we could train the model in the browser. So let me see if we can preview that here. So yeah, we were training and seeing after each epoch what how accurate the prediction was and what the loss was per each step. We were requesting predictions by hand, just trying to input a vector and then getting a prediction. And then we went into adding more data samples into this to actually get a convergence to the, getting the loss lower faster and converging to the proper results faster. So just by adding, we had 4 data samples, and just by adding 2 more, we had convergence that was a lot more accurate in 300 or 200 epochs, while before we were waiting 5,000 epochs and a lot more time of training. And we also saw how to load directly in TensorFlow.js, how to load a model from the TensorFlow hub. So we can load a graph model from a model URL hosted on the cloud, like the one I showed before with the Teachable Machine, and just passed a random tensor to make predictions and make sure that this was working, right? So we wrote an asynchronous function that was requesting a prediction and then outputting the prediction to the browser, and we made it work. So those 2 examples, right? So if you want to just test them, you can go to github.com/nonoesp/live, and in live 11 you can see both of those. So we can zoom in here, and the interesting code is inside of the script tag. You can see how in this case we load the model and then we predict, we print the tensor, and then log the tensor here. In the other example, what we do is, as I mentioned before, we define the model, compile it, get a callback to be printed every time or that an epoch ends. We actually predict with the model and print the result. We have our data here. What I mentioned is that by adding these 2 data samples, that 12 has to be 23, and that x, so y for x10 has to be 21. We make the model converge faster. So if you remove 3 from here and 3 from here, you'll see that the model will have a harder time fitting the linear classifier into that. We configure the model, setting the callback to on epoch end. We set 300 epochs, and then we feed the model. At every single time we're predicting, so this is something I got confused on the video, and you can see it on the video, is that you do model feed xs to ys, and then you set the config. So in the config, you set that a callback that on epoch end is actually going to make a prediction. But this callback is wrong. Actually, this callback is when you finish training, right? You have the model, you feed it, and then when you feed it, you do something. So this is actually a callback that runs when your model has finished training. These probably should go inside of here. And this is a sample function that doesn't work here. You just will have to wrap it inside of an asynchronous function to get it to run there. All right, so that's what we have here. And again, you can go to livestream 11 to watch that. I'm not going to go through it today, and that's all we had to cover today. So our model in TensorFlow.js from Lobe has been exported. So we have the signature, which tells us the information about the data types and the labels here, and the shape of the vector, the tensors, and things like that. And then we have the actual model that defines the layers and all the operations that have to happen in the model to run, right? So this is actually a definition of the model. And then we have these shards. So these shards go from 0 to 25 and are binary files that, you know, they are shards because they will get streamed or loaded in chunks, so you don't have to download one file at once, really. Just one file at once. Each of them goes up to 4.2 megabytes, and they all together make all the weights of the model. The model here is just a model. It's a weightless model. It's like 115 KB. It's really small. And then when you load the model, all these shards will get loaded as the weights of the trained model. What we have here is this package. So you just have like a TensorFlow.js application. It seems it's using TypeScript, and this is really nice. This is a really nice practice that the Lobe team is doing, and is that every time they ship a model, they also ship an example folder, and that example folder contains the minimum code that you need to run that model in production or in a sample app, right? In here, the TF.js app, right, what we can do is that, let's see if there are any commands here. So scripts predict, right? So if we do npm run predict, so let me just go to the left, and if we go here, so let me see, npm run predict, this won't work, right? Because we don't really have the models properly installed. We just have to do npm install or npm I, and once all of these dependency packages get installed, we will be able to run that command and make a prediction. So here, ts node tf.js example, and model path file, this signature file. So this code is referencing the file from the folder above, and inputs, image, shape, slice, 1.3, load, predict. Given an input image decoded by TensorFlow as a tensor, pre-process the image into pixel values, center, blah, blah, blah. So we actually need an image here. Main. All right, so now that this is working, so we can actually run npm run predict, and we'll get an error telling us that we need to provide the path of the image that we want to predict on. And that will be good because that means that this is working. So this says, the Node.js native add-on tf.js binding.node cannot be found at path. All right, let's try to get this working. And all right, rebuild dependencies successfully. So we just try to predict again. Hopefully we don't get the same error. All right, doesn't really work. Why not? Let's create a new terminal. npm run predict. Yeah, if this doesn't work, it's okay. We won't spend more time on this error right now. That's a bummer. All right, so what we can do is probably tf.js node. Okay, so yeah, that will run. We will specify the path of an image doing npm run predict, and then path to image or something. And, you know, that will predict with using our model and tell us what label the model is. It's worth exploring, so I'll take a deeper look at this code, and I'll add it to the live stream notes. So I'll add it here later. So we'll do the TensorFlow.js TypeScript example. TensorFlow.js model export TypeScript example of Lobe. All right. Yes. So we said we were going to take a look at the webcam, and I'm gonna go off here, try to play with the model and say camera. So now if we go here, we can select what camera we want to use. So I'm going to use the one I'm using for live streaming. So I have this camera here, and we can train a model live. So let's actually go out, and so we close this project and we put here, so my life, and we're going to create a new data set from scratch. All right. So here we import from the camera. Nice. So I don't really know up to what resolution we can do, but let's actually try to just add images here when I'm with my hands on the mouse. Oh, actually, something bad that I did is that these unlabeled images. So let's say like still. Hands down. Let me see if I can bulk select. Okay, yeah, I can bulk select. So I have this image labeled. All right, so I'm gonna add camera. I'm gonna put hands down, and I'm gonna keep adding. Right, so now I'm gonna put hands up, but I'm going to put this here. So I'll do this. A weird thing is that I have to have my mouse up to be able to do this. So all right. So you can see the computer is slowing down a bit, and this is training already. And maybe we can do, I don't know, maybe we can put the book here. So hands-on machine learning book. And it's a bit. So these are images that are gonna hopefully be classified as, oh, there's a book here, or specifically this book is on the image. And note that the image is being flipped, so you're gonna read the text, but I guess that this wouldn't matter. All right, and maybe we can just add the obvious, that is like green screen, and then I'm just going to add images here. All right, so what else can we do? Any suggestions on other labels that we can add? Okay, so while this is training, let me try to answer a question from Suje. Let me see. Now that we have a question online. Hi everyone, this is a question by Sujay Kumarji on the live stream. He's asking, how do we rate the accuracy of Teachable Machine versus Runway versus Lobe when it comes to image classification? So depending on where you're training and what type of model and what type of data and how data is being pre-processed, many factors, your model is going to be more accurate or less accurate in different types of data. In this case, all of these different tools, Teachable Machine, Runway, and Lobe, they're providing us with a way that we can they're providing us with a way to teach these models, right? To train image classification models without writing a single line of code. They allow us to just prepare a data set somewhere, then drag and drop them or add them with a folder, and then train the model and export it to multiple different formats, specifically Teachable Machine and Lobe. I'm not sure about how Runway at the moment is letting you train a classifier, whether it's doing it or not. The thing is, we can train this model to many different places, right? TensorFlow.js, TensorFlow Lite, TensorFlow Core, run it as a local server, many different things. But they are all using slightly different strategies. So they might use ResNet, the ResNet model that was created by Microsoft, or that is a deep residual network. They might use MobileNet. They might use Inception. They might use different neural networks to classify that are using different strategies to learn features from your images, to learn what makes an image label, an image type distinct from another. This means that the models are going to perform differently on the same type of data, and also differently in different types of data or different ways of formatting. But if we start and train the same, so different models in Teachable Machine and Lobe, for instance, using exactly the same data, we're also going to see different results. Different results because, for instance, Lobe doesn't let us change the amount of epochs or the learning rate or other parameters from a model, whereas Teachable Machine lets us do it. And if we use TensorFlow Core or TensorFlow.js, we're going to be able to customize everything up to the smallest level. This means that, those parameters are important, and we're going to get different accuracies, and there will be models that might classify some types of images better than others. So for example, line drawings might be recognized better by one type of network, and photographies might get recognized better by other networks. What I would recommend is that you understand really well what the confusion matrix is, what the accuracy metric and loss metrics are, and how to measure them. This means, for example, in Teachable Machine, we can see the loss going down over time, and we can also see the confusion matrix and the accuracy of the model. we can see those parameters changing as we train, and also how they evolve as we change the number of epochs that we have to train for, and the learning rate and other parameters, and the batch size, for instance. What you will do if you train these models in the different tools that we're seeing here with the same exact data set, you will save the models to the same format, say TensorFlow for Python, or TensorFlow Lite, or TensorFlow.js, and then try to run them through the exact same data set, so an evaluation data set, and try to create your own graph of accuracies, confusion matrix, and all these things. That way you will understand which of these models with the exact same data, maybe the same configuration like epochs or learning rates, is learning the better, or is better learning to classify your images. This is a common process. It's like you have a data set, say, okay, with this data, which model is going to learn the fastest, is going to train the fastest, or is going to be the optimal, is going to execute faster, and is going to classify my data better. I would say it's not only about the accuracy. Accuracy is really important, but there are other things like speed of execution and how optimal the model is, or how optimized the model is for you to be able to run it maybe on the cloud or on a device and have fast predictions. Sometimes we trade accuracy for speed. So maybe if you get a 99 or like a 97% accuracy in 10 seconds, it's better to get a 92% in half a second, because that's going to provide the user with a better experience. And I hope I answered your question. The gist of this would be different tools might use different neural networks. And even if they use the same neural network, they might use different strategies to retrain these models and to export them. Like, let's say one might export the TensorFlow Lite model as is. The other one might allow you to quantize it and have a bit or less accuracy with more performance. So yeah, different tools, different models, different accuracies, different results. But the most important, learn how to measure the accuracy of the models on your own, and then use the same evaluation data set on the various different models that you've trained to measure which one is the best for the use case that you want to use it. You might be looking for okay accuracy with really good performance, right? So you might be looking for good accuracy, but with a really good performance. Other days you might be interested more in having the highest accuracy possible, and you don't mind about performance because you don't have to execute things on real time. So yeah, I hope that this answers, and thanks for your question, Sujay. All right. So yeah, thanks for the questions, Sujay. I like those questions because then we can post them in case other people also have them. So let me go back here. I'm going to see, so we have this training set that we've shown before, in which we have the green screen label, but we have all images. So we have green screen, and okay, there is some lag. Let me try to see why that's happening. All right, I think I'm live again. Sujay, can you verify that the audio and the video line up correctly, or if we still have some lag in between? I see everything is okay on my end, so I'm not sure how this is happening. Can you verify that the video and the audio are matching? All right. I hope that the lag is not back there. I just checked on my phone and it seems like the audio, after I play back, the audio is matching properly the YouTube video. So I'm just gonna wrap it up now and hope that that's okay. But thanks for the heads up. Thanks so much for letting me know. All right, so I was saying this is Lobe. So we've trained a model with a webcam. Now they have this possibility of changing webcams to select which one you want to use for obtaining images. So we have the green screen here. So we have the hands down data set. So these are images where I'm just putting my hands down, and as I will do here, like just looking at my looking at the screen or looking at you, the camera, and having my hands on the keyboard, on the mouse. Hands up, where I will be like this, which is a bit weird because I cannot take images like this with my mouse because I need to be clicking on the image. So let's see how that works if I just do this with my hands. And then the hands-on machine learning book, which actually I was seeing the images flipped, but then now I see that the images are respecting the actual side of how the picture was taken, and we can read the title of the book. All right, so the model has been trained. So in training, we saw that every single class seems to be correct, which is really good. And now we can play. I don't know what will happen to my webcam. So it seems I can be here twice, which is good. And the model is loading. So we're probably getting the model loaded in TensorFlow Core or TensorFlow Lite. I'm not pretty sure, maybe even TensorFlow.js. Hands up, hands down, up. You know, this might speed down my computer a bit. It seems like the fan is switching on, but the good thing is that it works. If I go out, it says that the green screen is present, and if I get this book, it tells us that we have the hands-on machine learning book, which is really good. It's working perfectly. It's actually recognizing everything that we've wanted to classify, and that way we can train a model with our webcam, and now we could make use of it any way we want it, right? We will have to build a website, like an application like this one. This is actually an Electron app where our model is performing classifications and letting us know what label we're there's some glitches in there. Oh, my hands go out. And yeah, so this model works, and it's pretty cool because that way we could, even on the live stream, we could have something running and then letting us know whether something is working or not. It seems like there is something that this is recognizing of the book, right? Like when I have my hands here, the book, these are, when I have my hands like this, it's thinking that I have the book that I'm holding the book on my hands. I don't know if I can put a delay on the pictures. That would be a really nice feature if I can put a delay to take the pictures, because otherwise I don't know how to click now the mouse to add this image to the data set. Maybe something like this. Yeah, I don't really know. So let's see if that got added there. Yeah, so hands up. Yeah, so you get the point. So this is a really nice example. We can use it later. I'll share this video as a separate clip. And I also like that Lobe doesn't change my webcam configuration, so I can be here and live streaming while my image is in there. So that was the Nonoma live test. So we could use this as I'm live streaming to recognize different positions of my of my body, and then maybe stop recording when I'm out of the screen. Or if I put hands up, like maybe the video stops recording or live streaming or something. So yeah, that was an experiment. So we also have this JavaScript model that we exported. I'm actually going to delete it because we can export whenever we want to. And I'm going to go here. All right, so let me just open the outro video here. So we have this presentation here. And once again, this was one more video of the machine learning series. Go ahead and like the video if you haven't done so. If you want to let me know that you enjoy the content or you would like to see similar videos. Subscribe if you want to get notified when I go live in the future or when I upload new videos. And join the Discord community. Join us there. It's a place where you can share your projects. We can discuss things that have to do with machine learning, podcasting, sketching, drawing, creative coding, anything really. And we can get to know each other a bit more. Thanks so much for watching, and I'll see you next time. Bye, and thanks for being there. Bye bye.